Hello, welcome to my channel. We have been doing this past papers. So right now I have this mathematics probability and statistics one. Okay. And we are doing May, June 2024. So let's go to question number two. I am skipping question one right now. I will do it later. So let's do question number two. Okay, the lengths of the tail of adult raccoons of a certain species are normally distributed with mean 28 centimeter and standard deviation 3.3 centimeter. Find the probability that the adult raccoon. Okay, so uh, we have some distribution for a adult raccoon's tail, and the mean is 28 centimeter. Here's the length of the tail. Okay, so it is normally distributed. So something like this. The curve of this distribution is something like this, and it has a standard deviation of 3.3 centimeter. Okay, now we have to find the probability that a randomly selected adult raccoon has a length between 23 and 35 centimeter. So somewhere 23 and 35 somewhere here. So we have to find the total area between these curve, right? Between these lines. Okay, so what we will do, instead of working on this curve, we will work the standard deviation curve whose mean is 0 and whose standard deviation is 1. The variance is 1. So I call it Z. Okay, so how can we transform this variable L into variable Z? There's a standard formula for this. Z is equal to L minus the mean value. Okay, so like how should I write L? Mean value of L divided by the standard deviation. Okay, so let's see. When L is 23, the Z would be 23 minus the mean, which is 28, divided by the variance, which is 3.3. And this will give us the value. Let's see, calculated before. It will give us the value. Yeah, 1.515. Okay. 1.515. Okay. And when L is 35, Z would be 35 minus 28 over 3.3. And this will give us a value of 2.121. Okay, so now we have to use the, okay, why we have transformed this variable z into a standard deviation, which is mean 0 and variance 1, because we have the tables available for this one. Okay, so now the probability of this one, it is same as the probability when it is 23. So sorry, this is negative. So from here minus 1.515 to here somewhere 2.121. So what is the probability that of this area? Okay, so we need to find this area now. Okay, okay. I hope you know that there are Q functions. Q functions are the tables where they give the area of this curve when x is from here. Okay, so when x is 0, the total area is zero point 0.5. This is x and this is q of x. Okay, so when x is 0, the total area is zero point 0.5. Okay, and when x is infinity, of course, when x is increased to infinity, the total area is 0. Okay, so this table is available. Let me show you let me share this table with you. How can I do that? Hold on a second. Okay, sorry, I am a little lost here. Yes, okay, now I can show you. Okay, yes, application window, yes. Okay, yeah, this is the Q tables. So you can see when the value of X is 0, the total area is 0.5. Okay, when it is 0, the area is 0.5. When X is increasing, the area is decreasing. Okay, so anyway, I will show you how to use this table. Okay, let's go back to our problem. Uh, I'm sharing this thing again with you. Okay, yes. So now the probability what we want to calculate, okay, that probability is this area, as I said, remember? Okay, so how can I find this area? If I do 1 minus q of 1.515, okay, what is this area? It will be the area, okay, if I have this curve, normal curve, right? So if it I have 1.51 is here, right? So if I use q of 1.51, it will give me this area. So 1 minus q will give me this whole area, right? So which is this whole area. Okay, from this whole area, I have to subtract this one. So this is minus q of 2.121. Okay, so I have this is clear that the required probability is 1 minus q of this minus q of this. Okay, so when we use this table, so q of we need to calculate for 1.515 and 2.121. So let's go back. Let me share this other thing. Yes. Okay. Okay. So 1.515. So 1.5 and 1. Okay. This is okay. 515. I will approximate it to approximate it to 5 to 1.52. So this is 1.52. Okay. You see 1.5 and zero point 0.2. So this is 1.52. And the next value 2.12, I will approximate is 2.12 only. So 2.1 and 2. This is the value 2.12. So this is the value I am looking for. Okay. So these two values I will use in my calculation. So let's go back here. Uh, share this thing again. Yes, okay. So it is 1 minus and q of this, we saw the cal table, it is 0.06426 minus this value was 0.017. So the answer is going to be 0.91874. So this is the probability that a randomly selected raccoon has its tail between these values. Okay, I hope you understand the philosophy of this question and how do we use this Q table and what's the meaning of these Q tables. Okay, now the next question, the message of the adult raccoon of this species are normally distributed with mean this and variance unknown, right? Here the variance of the standard deviation is unknown. Okay, so we understand that what in this time the mean is 8.5 kg, right? And it has some variance which is not known. So the distribution of the uh, uh, weight or the mass of the adult raccoon is distributed like this, something like this. Okay. So again, I will convert this, if I call it M, I want to convert this M into standard variable Z, which is normally distributed with mean 0 and variance 1. So this is the variable z whose mean is 0 and variance is 1, right? Okay, how can I can make m into z? Of course, z is equal to m minus the mean value of m divided by the variance, right? Okay, so uh, we have to find this M is 7.6 kg, right? Okay, so 7.6 minus mean value is 8.5 over the variance which is not known. So this comes out to be minus 0.9 over variance, right? Okay, so this is negative number, so it is somewhere over here, right? So all this area, right? This represents the probability that okay, and the standard deviation, yes, 75% of the raccoon fall in this range. So if I have a raccoon whose mass is 7.6 kg, right? 75% probability is that it is sorry. uh, yes, uh, I'm sorry. Yes, 75% adult raccoon, they fall in this range, right? So it means that Q of this value, this is 0.75. The probability is 0.75. Okay, and this is equal to okay, the probability is 0.75. So this is equal to 1 minus Q of this value. Okay, if I take the negative, remove the, it is 0.9 over sigma. So this is Q of 0.9 over sigma. Okay, I hope I am clear here that the probability of this thing, it is 0.75. Okay, to read this statement again, 75% of adult raccoon of this species have mass greater than 7.6, right? So the probability that the mass is greater than 7.6 kilogram, it is 0.75. So the probability is 70.75, 75%, and the mass is 7.6. The 7.6 translated into the normal variable z, it is minus 0.9 over sigma, and the probability is going to be like this. Okay, from here we can see that the Q of 0.9 over sigma, it is equal to 1 minus 0.75, so this is 0.25. Okay, so now I have to find the value of this Q. Okay, the value of the Q function is known. So what is the value of this X? Okay, so I will go to the table again. So now I have to work opposite way. So I need to find this number corresponds to which X. So Q of what number corresponds to this number 0.25. Okay, so let me go back to this uh, table. Okay, so 0.25, it is, you can see 0.25 is 0.6. Okay, 0.25, this is the number which is closest to 0.25. Okay, so this number is closest to 0.25, and this corresponds to 0.67. So you can see that Q of 0.67 is equal to, or is no, closely equal to 0.25. Okay, so we will use this number. Okay, let's go back again. Yes. Okay, so this number came out to be 0.67. Okay, I hope it's clear. So from here, sigma is equal to 0.9 over 0.67, which gives you 1.3433. Okay, I hope this is clear that the distribution of this masses, we knew that the mean value was 8.5 kilogram, but we didn't know the variance, the standard deviation that we calculated now. Okay, I hope you understand this question again. Let's go to the next one. Okay, the heights in centimeter of 200 adult Bairima are summarized in the following table. Okay, I don't know what this is. Anyway, so draw a histogram to represent this information. Okay, so we have to use this height on the x-axis and the frequency on y-axis. So let me sketch this thing. Let me show you how we sketch. Okay, this is need to make maximum space available. Okay, here we go. Okay, so let's make a horizontal line for the height here. And I started from 130, 140, 150, 160, 170, 80, 190, and it is 200. Oh, no, 200 is here, sorry. Okay. Now, here's the height in centimeters along x-axis, and the frequency I'm doing on a y-axis. So let's say this is 20, 40, 60, 80, and that's it. Okay, so 130 to 150, 130 to 150, there are only 16. So this is 10, uh, 2, 3, 4, 5, 6, 7, 8, yeah, here. Okay, so I will make it a histogram like this. Okay, so when H is between 130 to 150, the frequency is 16. From 150 to 160, it is 32. So this is 13, this is 32. Okay, okay. Now from 160 to 170 to 76. Okay, this is 70 and 2, 3, 76. 160 to 170, yes. Okay. Okay, so from 170 to 175, this is 175, right? It is 64. So this is 60, here 64. Okay, and from 175 to 195, this is 190 and this is 195. Okay, it is 12 only. So 1, 2, 3, 4, 5, 6 here. Okay, so this is the histogram they're asking us to draw. I hope it is clear. You just when you're doing an exam, you just have to be a bit more precise. Okay, now the next question. The interquartile range is R centimeter, show that R is not greater than 15. Okay, very good. We will work over here. You see, what is the interquartile range? Uh, interquartile range, yes. Interquartile range is when, what is the range where this from 25% to 75%, right? Okay, so you can see that up till here we have 16, up till here we have 16 plus 32 is 48. So from in this range we have 40, the 50% rise in this range. 50% lies in this range, right? In the same way, 70, when I add into, here you go, sorry, 16 plus 32 plus 76. Okay, it is 124. And then I add into 64, it is 170, 188 divided by, yes, this is giving me 95%. Okay, so in this range, I have the 75% lies over here. Okay, so I will solve it over here. So the lower interquartile range, it lies between 160 and 170, and the upper or higher quartile range, it lies between 170 and 175, right? I hope it's clear that 25% of this, all the data is between this range, somewhere in this range, and 75% is in this, somewhere in this range. So the interquartile range, that is from here to here, in this, somewhere in this one. So uh, our interquartile range, it is between 160 to 175. So if I find the difference, it is uh, R is equal to 175 minus 160. So this is 15 only. Okay. So the interquartile range is 150 on 15 only. Okay. So this is question number 3. Okay. Okay, so we will do other question in the uh, video. Thank you very much for watching. If you find these videos helpful, please subscribe my channel. Thank you very much for watching. See you in the next video.